Alright, today we are going to be learning how to draw Lewis structures. This is going to be just the first video. I'm going to have a second one with some more advanced problems. This is just the basics today. And Lewis structures are basically drawings of molecules, and they show how atoms are going to be bonded to each other. Alright, there are some symbols that we're going to take a look at and what they mean, because we're going to be using these symbols for the rest of the week. Whenever you see a dot, that is going to equal 1 electron. Okay, whenever you see a line, that's going to represent a bond. So whenever you see this, that represents a bond, and just a single line, that is going to represent a single bond, which is 2 electrons. All right, so that also equals 2 shared electrons. All right, whenever you see two lines like this, that is going to represent a double bond. Alright, and that is going to be, excuse me, 4 shared electrons between 2 atoms. Alright, and then if you see something like this with 3 lines, that is going to represent a triple bond. Alright, and that is going to represent 6 shared electrons. Alright, so let's take a look at the rules for learning how to draw Lewis structures. Alright, so go ahead and hit pause and write these down. Okay, let's take a look at rule number 1. The first thing we're going to do is we're going to count the total number of valence electrons. That means you look at what group that element is in and you write down its valence electrons. And then we're just going to add all of them up. So we're just going to get the total. Now, if we have an ion, and if it's negatively charged ion, so if it's an anion, you're going to add 1 to the total number of valence for every negative charge that there is. If it's a positive ion, you're going to take 1 away. The next thing we have to do is determine the central atom. Usually that's the thing that there's only one element of, or the element that's kind of to the least, or I'm sorry, excuse me, to the farthest left on the periodic table. Oftentimes it's going to be carbon or nitrogen. Just as a friendly reminder, if you have something like carbon and nitrogen, those are the two that are most likely going to be in the central atom if it's in your formula. Alright, you're going to write down your central atom, and then you're going to draw a single bond that connects all of the atoms to the central atom. Alright, so try to make sure it's symmetrical. Alright, in step number 4, we're going to make sure everything has 8 valence electrons around it, and make sure everything follows the octet rule, and hydrogen is going to have its 2 valence electrons, which is just one line. And then we're going to check our electrons to see if we need to add a double or triple bond, and I will show you how to do that in just a few moments. So let's go ahead and let's take a look at an example. Alright, so we have right here, remember this is from naming, this is going to be nitrogen trihydrate. Alright, or also commonly known as ammonia. Alright, so what we're going to do is we're going to take a look and see, well, how many valence electrons does it have? So for nitrogen, it's in group 5, so it has 5 valence electrons. For hydrogen, it's in group 1, and there are 3 of them, so we're going to take 1 times 3, which equals 3. We're just going to add these up, and you have 5 plus 3, that gives me 8 valence electrons. Alright, I need to determine my central atom, so I look at here, it's just so you know, the central atom will never be hydrogen. Okay? That will never ever be your central atom. Alright, so it's going to be nitrogen. So I take my nitrogen, I draw my N, and then what I do is I just bond everything else around it. So I bond a hydrogen to this, I bond the other hydrogen, and I bond the last hydrogen to my nitrogen. Now what I have to do is count and make sure everything follows the octet rule. Alright, so whatever this bond touches, it shares 2 electrons between those 2 atoms. So this hydrogen right here is sharing this electrons right here with this nitrogen. This right here is sharing with the nitrogen, and this hydrogen over here is sharing with the nitrogen. And also, since the nitrogen is touching those, it's sharing all of these electrons as well. So each hydrogen is already happy, okay, because it has its 2 electrons. That's all you have to do. So don't draw any dots or valence electrons around the hydrogens. Now let's take a look at nitrogen. So when you count up the valence electrons, you say, okay, here's 1 and 2, here's 3 and 4, and here's 5 and 6. Remember, each line represents 2 dots, or 2 valence electrons. It has 6. We need a total of 8. Hydrogen needs 2 more, so what I'm going to do is draw 2 valence electrons on the hydrogen. So let me redraw this for you real quick. Okay, and it looks like this. Okay, and that is the Lewis structure for drawing ammonia or nitrogen, trihydrate. All right, so notice that the nitrogen is going to need 2 more dots because it needs 2, 4, 6, 8. It needs 8 valence electrons around itself because we need 8, and we only had 6, so that's why I added them around the central atom, and each hydrogen has its 2. All right, let's take a look at this one, HCl. Okay, notice that this is going to be a chlorine. Remember, I said I'm going to try to write my chlorines in cursive just so you know that that's chlorine and not carbon and iodine. So you say hydrogen, all right, it has 1 valence electron because it's in group 1. Chlorine has 7, and you add that up, it has 8. There's only 2 atoms here, so there's really going to be no central atom. So if you only have 2 atoms, just bond them together like this. Now let's check our electrons and check everything else around it. The hydrogen has 2, it's happy. The chlorine only has 2 right now. Okay, notice it only has 1 thing bonded to it, so we have to draw in the remaining. So let's go ahead and put 1, 2, 3, 4, 5, and 6. Let's check and make sure we have a total of 8. 2, 4, 6, 8. And that's how many we needed, so this checks out good. And chlorine is happy, and the hydrogen is happy. So that is the correct Lewis structure for drawing HCl. Let's take a look at this one right here, SF2. All right, so S, check our valence electrons, has 6 because it's in group 6. Fluorine, all right, that has 7 valence electrons, but there are 2 of them, so you make it multiply it by 2. So 6 plus 14, you add that up, and that gives me 20 valence electrons. So we have to determine the central atom. There's 2 of these and 1 of these, so this right here is going to be my central atom. Just as a friendly or as a hint, usually whatever's first right here will probably be the central atom. All right, that's kind of a nifty trick right there. All right, so we draw our sulfur in the center, and we bond everything else to it. So we have 2 fluorines we got to bond to it. And now let's just make sure everything has 8 valence electrons. So fluorine only has 2, so let's go ahead and draw in the remaining 6 electrons. We're going to make sure we have 6 valence electrons around this fluorine right here. Alright, now let's check the other fluorine. Since it's the same thing, it's symmetrical, we're just going to go ahead and add 6 valence electrons to this. So we go ahead and put in our 6, F looks a little funny, our 6 valence electrons. So we say, okay, 2, 4, 6, 8, 10, 12, 14, 16. Alright, fluorine is okay, this fluorine is okay because they both have 8, but let's take a look at the sulfur. It only has 2, 4. Remember, whatever it touches, that bond, that's how many it has. So it only has 4 right now, so we have to draw 4 more. 5, 6, 7, and 8. Now when you check this, you have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Everything checks out, 20, and we have 20, so we're good with this one. So we can go ahead and move on to our next example. Alright, carbon tetrabromide. Alright, so carbon is probably going to be my central atom, and yes, it's going to be. So carbon, alright, that has 4 valence electrons. Bromide, or bromine, has 7, but there are 4 of them, so we got to add this up, and we have 32 valence electrons. So we draw our carbon in the center. We're going to bond the 4 bromines around the carbon. Okay, and take a look at carbon. 2, 4, 6, 8. Carbon's already good. All we have to do is draw in the remaining valence electrons around each of the atoms. Remember, you just check every atom just to make sure they all follow the octet rule. And that's all you have to do. So I'm going to go ahead and fill this in for you. When I come back in just a second, they'll all be filled in. Alright, I'm back, and let's take a look at this now. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We need 32. We have 32. So we are good with this problem. Alright, let's take a look at a next one. O2. Alright, this one gets this is when the fun starts to begin. So we say oxygen, all right, it's in group 6, and there's 2 of them, so that is going to equal 12 valence electrons. Now, let's take a look at how we do this. So we draw an oxygen, we bond it to another oxygen, and we just check our valence electrons. There's 2. Everything needs 8, so this one needs 6 more valence electrons around itself, and you just represent that by dots. Okay, you just draw a couple more dots around here to represent valence electrons. All right, and let's check our total. 2, 4, 6, 8, 10, 12, 14. Uh-oh. We needed 12. We have 14. When this happens, what we are going to do is we need to add a double bond or a multiple bond. Alright, so when this happens, when you have more than you need, what you're going to do is you're going to, make sure you pay attention, you're going to get rid of one lone pair from both bonding atoms. Alright, so you just get rid of a lone pair from each of them, and then what you're going to do is you're going to add a multiple bond. So you're going to add a second bond. So this is what your molecule becomes. You have an oxygen, now we have a double bonded oxygen. So now, instead of sharing 2 electrons, they're sharing 4 electrons. So this is 2, 4. So let's just go ahead and put in our remaining valence electrons. Okay, now let's go ahead and add these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have the 12 valence electrons we need. So this right here is the correct Lewis structure for drawing oxygen, or molecular oxygen, which is the oxygen we breathe, the O2 molecule. Alright, so let me go ahead and repeat that just one more time. What happens is if you have too many, and we need 12, and we have 14, so when you have too many, you take one bonding pair away from each of the bonding atoms. Whatever the bond is going to go between, you take one lone pair away. So I took 2 away from right here, just cancel them out. And I take these 2 away and cancel them out, and I add another bond right between the 2. Okay? And that's what you do if you have too many. And sometimes you might have to do this 2 or 3 times, so you might end up having a triple bond right here. And this is going to be our last example that I do. It's N2. So we take a look at the nitrogen and we say, alright, nitrogen, you are in group 5 and there are 2 of them, so that is going to leave me with 10 valence electrons. I'm going to I'm going to bond my nitrogen to the other nitrogen, and I'm going to draw in its valence electrons. Oh, let's change the color up a little bit. So this has 2 valence electrons, so I need to add 6 more to each nitrogen. And now we check our total. 2, 4, 6, 8, 10, 12, 14. Alright, we have 14 again. Now what do you think we do? That's right, we need to get rid of 2 lone pairs. So we get, by the way, these are called lone pairs. Okay? Those are these electrons right here, the lone pairs. Those aren't responsible for, or those aren't bonding at all. They're just there. Oftentimes, I represent those as LP. Right? So we get rid of one of those, and we add a multiple bond. So now let's take a look at what we have here. So nitrogen becomes this. So we have a double bonded nitrogen. All right. So we have 4, 5, 6, 7, 8 there. We have 1, 2, 3, 4 on this side. So we have 5, 6, 7, 8. Now when we add these up, 2, 4, 6, 8, 10, 12. Now we have 12 valence electrons. Alright, so what we are going to do is we are going to do the same thing one more time. Alright, so I'm going to go ahead and get rid of one lone pair on each of them, and I'm going to add another bond. So now my structure starts to look like this. Alright, I have a nitrogen, a triple bonded nitrogen, and I have a lone pair on each of these. So I have 2, 4, 6, 8 on this side. So he's sharing these over here. 2, 4, 6, 8. So this nitrogen really is sharing 6 electrons. This one is sharing 6 electrons. And 2, 4, 6, 8, 10. Now we have our 10 valence electrons that we needed. So the 10 checks out, and we are good with this molecule.